Hi everyone, I'm Shubham Garg and welcome to this lecture series of Layout Editor, Microwind Layout Editor. So in this series, I'm going to tell you about the Microwind Layout Editor. Till now, we have been working on the DSCH, that is the schematic editor. And in this playlist, we are going to see the layout editor. Alright, so if you want to know how to download and install this Microwind DSCH and layout editor, please watch the video in the Microwind DSCH playlist. In that video, I have made a video of installation of download and installation of DSCH. So from that you can learn how to download and install this layout editor. Okay, so now when you open that layout editor, that is this Microwind 3.5 layout editor, you will see a screen some kind of like this. So this is the kind of screen you are seeing. Okay, and there are some of the options. First of all, if you remember in DSCH at this side there were the symbols and components like NMOS, PMOS, etc. However, in this there are layers which we are going to make the layout. So basically what happens that in a circuit, whenever we make a layout, we need to use different layers. That is, when we make the drain, we make the source, when we make the substrate, when we make the gate terminal, we need some specific layers to make these terminals. So these layers that are mentioned here, metal to metal 1 contact, polysilicon, P diffusion, N diffusion, N well, these kind of layers are used. So in this video, I'm not going to show you any circuit or something. No, we are not going to make any circuit. I'm just telling about different options. Okay. So what is actually happening here? Now from here we can select the layer and I can draw any layer I want, like this, or any layer. Here I can draw. Similarly, I just need to select any other layer. From here we can draw like this. So deleting a layer is simple like that. Okay, and one more thing, let's say we draw this layer and now we need to extend it or increase its size. So what will happen, we need to select the stretch or move option. So we just need to select the layer, hold the mouse cursor and drag to the side. We need to stretch like this, and once we do that, we will be able to stretch from that side. For example, like this, I am now able to stretch from top. Similarly, if I do this, I am able to stretch from bottom. And let's say you need to move the whole layer. You just need to select this whole layer and you can move it anywhere. All right. So these are some of the options for layer. Okay. These are options for the supply, that is VDD, ground, clock, these supply. If we need to add this supply, we can add by clicking it and like this. So this is how we add the supplies. Okay, these are the options on top, that is the contacts. We are going to see what the contacts are used for. Okay, in the videos where we will see any designs and all. Okay, and there are some resistance, capacitance, inductance options as well. And this option is a MOS generator. So basically, like when we generate a layout, we can generate any circuit. We need to generate the MOSFET, that is PMOS, NMOS, and all of that. So we need to make the layout of PMOS and NMOS. So here this MOS generator, this already automatically makes the layout. Like here we can select the MOS and we can select which MOSFET we need, that is either PMOS or NMOS, and it will generate the layout. This is just to make our work easier, so that we are able to, we do not have to waste time in making this MOSFET, because most of the circuits require MOSFET, so we can directly use like this. And you can see this is kind of how a PMOS looks like. Okay, this is the it is NMOS. This is how an NMOS looks like. So we are going to go into the detail later on, that what are these layers, what is this green thing, this blue thing, everything we are going to go into detail later. Before that, I want to specify one thing in this video, that every layer has some certain rules, that is the DRC rule, design rule check, DRC. So you can see this option here, this is design rule checker. So when we click on that, we can see on bottom left we find no design rule error. That means this layout has no errors. Okay, so we need to make sure that our layout has no errors. Otherwise, if there is an error, then it will not simulate. So now what is what these error basically determines? There are basically certain rules between the distance of various layers. That is, the width of this red layer, that is the polysilicon layer, should be at least 2 lambda. Now talking about lambda, basically this is the unit we measure the distance whenever we make the layout in any of the software. So you can see on this top left, it is showing that this much distance. Okay, that is distance between these two dots. This much distance is approximately 1 lambda, and it is also showing the distance in microns. That is, it is approximately 0.600 microns. So so that basically there are certain rules. That is, for example, this poly cannot be less than 2 lambda. Okay, for example, I just reduce the height, reduce the width of this poly. So you can see when I reduce the width of this poly, it is saying too small. Now when we go for DRC check, okay, so right now it is not showing any error. Yeah, so let us use another polysilicon, and we will make this, okay, a polysilicon like this small. Okay, it is not allowing us to make this small polysilicon. Yeah, let's see now if it gives DRC error or not. And you can see here it is saying the design rule error detected, and this extra poly surrounding this is less than 2 lambda. So there are various rules for various layers. You can go to help and you can see in the design rules that you can see this here the distance between this little layer, Envel layer, and P plus diffusion should be R203, and R203 is here this value, that is 6 lambda. Similarly, the difference between Envel and N plus diffusion should be R204, and R204 is again 6 lambda. So these are the kind of distance. Similarly, you can see here the for polysilicon, this width should be R301, and 301 is 2 lambda. So this is how, and it is also shown in micron, so micrometers, that is, this should be the distance. So these are some of the rules, and you can check the rules, and from the design rule checker we need to check these rules. So this was about the introduction to this Microwind DSCH. Now I will show you, tell you about the different layers of Microwind DSCH, that is different layers which we are going to make, and how this thing, you must be wondering like how this thing is an NMOS, like you just it is not just randomly selecting layers and adding it, it is in a particular way. I will show that in a moment. So now I am going to show from this PPT how that layer, how that thing depicts NMOS and PMOS. Okay, so we can see here, this is the structure of PMOS and this is the structure of NMOS. So what is actually happening? What is actually happening here? We can see, first of all, both of the structure have a source, drain, and a gate terminal. So you can see that source is connected to P plus in this PMOS, that is the P plus diffusion, that is P type doping, and drain is also connected to P plus. The gate is connected to polysilicon. Okay, and here this in the case of PMOS, there is this N type substrate, that is the N-well. Similarly, in the case of NMOS, there is this P type substrate, source and drain are connected to N plus diffusion, and the gate is again connected to polysilicon. Okay, so now what these things are depicting is, I will just show you here. This you can see, this is the image of an inverter. This is the layout of an inverter. So now what is actually happening here, that this layer, this green thing is the N-well. You see in this previous slide, we need to, for the PMOS, we need this N-type substrate, that is N-well, on which the whole MOSFET is built. So this is this N-well, okay, and this red thing is the polysilicon. Okay, so that is the gate input. So you can see gate is connected to polysilicon, that is gate is actually made of polysilicon. So this is the polysilicon gate layer. Now this brown layer is the P plus diffusion. Alright, so you see both the source and the drain are connected to this P plus diffusion, and P plus diffusion is on the N well. So you can see this green layer is the N well, this is the P plus diffusion, and you can see these terminals, these are the drain and the source. That is, this one is the source and this one is the drain. Alright, so now these source and drain need to connect the source and drain to the diffusion. We need first of all we need to know that gate is made up of polysilicon and the source and drain are made up of metal. So the source, we can see this blue layer is the metal one. So this is the metal one layer, and this source is connected to VDD here, and this is the drain, so it should be giving the output. All right, now talking about the NMOS, this thing is for PMOS. Okay, and now we will come towards the NMOS. So for NMOS, there is this p-type P-well, that is p-type substrate. Now I need you to remember that in any layout editor software, there is one thing, that whole layout, that is whole screen, this black screen which we are seeing, this whole thing is a P-well. All right, so that's why we do not have to make any separate P-well here. Okay, like we have to make this N-well here, but the whole layout is a P-well, so we do not need to make any P-well. All right, so we do not have to make P-well. Similarly, the way we added P plus diffusion, this is the N plus diffusion layer here, and again this is the metal for drain, this is the drain, and this is the metal blue layer, this is for the source. Now you might be wondering what is these crosses. So you remember just now a few minutes before I told that there are some contact, that is p-type contact, n-type contact and all that. So you see when we make the layers, just by intersecting the layers, the software will not know that these are connected together. That is this metal layer and this p diffusion are intersecting, but to make sure that they are connecting, we need to make the contact. So using the contact, this metal will get connected to this. Okay, like here in this this p diffusion is crossing the polysilicon. However, there is no contact, so it is not going to touch the polysilicon. All right, so we need to make the contact like this, and similarly here. So now these are the types of layers, and this upper one is the PMOS and the lower one is the NMOS. This is the structure of an inverter. So now you might be wondering like how it actually looks like an inverter. So let me just show you. This is the actual 3D view. So we can see here that this is our PMOS, okay, and this is our NMOS. So you can see this whole thing is a p-type substrate. As I told, that whole layout is the p-type substrate. So here we need to add the N-well, that is for the PMOS, and you can see this is how the poly is connected, and here we do not have to add any well, okay, because it is already p-type substrate, and this is how the poly is getting connected. And this we can see how the doping is being done. These are these layers. So this is how actually the layout of an inverter and a layout actually looks like. Okay, so I hope it is a bit clear about what a layout is and how do we generate a layout. All right, so and one thing we need to make sure that we need to check the design rules, that is if our design is correct or not. So you can, for that you can again go to help and see the design rules manual, so you will be able to understand all the design rules. So I hope it is clear, the layout design, what is a layout design is clear. So I hope you are able to understand. I will just open an example design to show you how a complicated layout actually looks like. So let's see, let's open this layout. So we can see this is one of the complicated layout. So this is how a layout is actually looks like. We can open any other example as well. All right, so these are basically different kinds of layouts. You can see this is another kind of layout which is already made. Okay, so I hope the layout tutorial is clear, layout introduction. So this is all for this video. In the next video, we are going to make the layout of an inverter. So this is all for this video. See you guys in the next video.